Thanks everybody for joining today's BSG Professional Group Seminar. We're very fortunate today to have Dr Andrew Farrant from the British Geological Survey to talk to us. Andy is the regional geologist for South East England at BGS. Of course, in addition to his specialisms in geological mapping and 3D geological modelling, he's also got particular expertise in karst and has worked on karst around the world, not just in the UK. And as obviously part of his fascination for karst, he's an active caver and is currently treasurer of the British Cave Research Association. So I'm going to pass over to Andy now, who's got a talk on unconventional karst, exploring Britain's lesser known soluble rock landscapes. Over to you, Andy. Thank you very much.
Thanks for that. Yeah, I work at the Geological Survey primarily as a field geologist, creating geological maps and 3D modelling. But as I did my PhD on landscape evolution and karst at Bristol University, and when I joined BGS, I was put onto the chalk in South East England, and I thought, oh my God, this is going to be really boring, because I was much more used to sort of the Carboniferous limestone and karst environments. And as it turns out, it's actually quite karstic, which I'll talk about in a bit. But yeah, so it's been a voyage of discovery over the last 20 odd years in terms of understanding the karst in the UK. But yeah, so unconventional karst. So yeah, so basically, we've got a very wide distribution of soluble rocks in the UK. Most of the karst that most people think of, like places like Cheddar Gorge, Gaping Gill, Peak Cavern, and all the kind of famous karst sites, and the big cave systems are usually developed in some of the Paleozoic limestones, usually the Carboniferous limestones, and or the Devonian ones down in Devon, or the Cambrian limestones up in Scotland. But there's actually a lot of other soluble rocks in the UK, ranging from the Neoproterozoic metacarbonates up in Scotland, all the way down to the Cretaceous chalk and everything in between. So you've got Jurassic limestones, you've got Triassic calcareous breccias and gypsum, Permian gypsum and dolomite, and Triassic salts as well. So, and of course the chalk as well. So I'm going to talk more about kind of the karstic features we get on those kind of rocks, mostly on the Jurassic and the Cretaceous. So because most people are quite fairly familiar with the more classical karst areas. So this is what most people kind of familiar with when they talk about karst. You have places like this in Thor's Cave in Derbyshire, big cave systems like Unconventional Karst in South Wales, the Peak Cavern and the springs at Castleton, Cheddar Gorge, and other gorges like Burrington Combe and Troutgill, for example, Wookey Hole, Big Springs, limestone papers up in Yorkshire, big collapsed dolines this is in South Wales, and obviously the cave systems such as Gaping Gill. So that's what kind of most people are familiar with. But there's actually a lot of other karsts in the UK. I'm going to run through some of these features that you can see in these other karst areas. So starting off in the Permo-Triassic and then working our way up through to the chalk. So so Permo-Triassic karst. Well, this is mostly focused on the Permian dolomites and gypsum up in North East England. We've also got Triassic salt fields in Cheshire, but also some karst developed in some of the marginal breccias in and around the carb limestone outcrops in the Bristol area, so around the Mendips and across into parts of South Wales. But the most prominent the most prominent karst features you get up in the Permian deposits are basically due to the dissolution of gypsum within the permanent succession up in North East England, particularly around Ripon. And in these areas here, we've got a series of dolomites, so the KB formation, formerly known as the lower magnesium limestone, but interbedded with gypsum deposits, so the England formation and the Roxby formation. So you can see here that you got this quite a succession of dolomites interbedded with gypsum. And in the Ripon area particularly, these are been known to undergo quite extensive dissolution and creating lots of dissolution sinkholes and dolines. So just as a digression, the people use the term sinkhole for almost any kind of sort of dissolution work, any sort of collapse feature, be it collapse due to dissolution, collapse due to old mining, or even in some cases a burst water main. So we have to be a little bit careful about what we term a sinkhole, because that can have different connotations to different people. It's very loosely used by the media in particular. So probably best to use the word doline for these natural dissolution features. But in and around Ripon, we've got many collapsed dolines due to dissolution of the underlying gypsum. And because gypsum is so soluble, it's much more soluble than limestone or dolomite. These are actually ongoing features, and actually you can see here this map showing you where some of the more recent collapses have occurred. So we've got collapses back in the 1800s all the way through to the present day of it, and so that house down there is one that occurred relatively recently. So that does have a massive impact on planning and development and infrastructure development in and around Ripon. So just take care when you're buying a house, if you're buying a house in Ripon. So I won't talk too much about that. One of my colleagues, Tony Cooper, has done an awful lot of work on the gypsum deposits and the substance risk associated with them, and likewise on the Triassic salt deposits in Cheshire, which have also got some natural karstic features, although a lot of the dissolution in substance there is due to brine mining. So I'm going to talk mostly about the Jurassic karst environments and also the Cretaceous ones as well, the chalk. So obviously, most people didn't realise that most of our Jurassic rocks occur in a band from the North York Moors all the way down to Dorset, and then up into Cheshire and up into towards Blackpool. Sorry, up into Cheshire rather. And then it's got a series of different limestone units within that. So it's independent sequence of mudstones and limestones. But the principal areas where we've got karst features are in North York Moors, where we've got the Corallian limestones outcropping. Portland limestones down in the south and in Dorset. Lincolnshire limestone in the East Midlands. Cotswolds, where you've got the inferior and the great oolite groups. East Mendip and the Bristol area, where you've got some lower Jurassic limestones, the blue lias in particular. The Vale of Wardour, where you've got Portland and Purbeck limestones. But also some up in Skye as well, up in the big, up in the very west coast of Scotland. So that's the kind of areas where we get most of the karstic features. So talk about here. Think geomorphological features like dry valleys, sinking streams, caves, dolines, and big springs. So North York Moors. This is an interesting area. So you've actually got some really quite significant karstic systems here, mostly where streams and rivers coming off the rocks of the North York Moors, when they drain south to the Vale of Pickering across the Corallian oolite formation. These are a series of calcareous sandstones and oolites. Often, a lot of these rivers actually sink underground and then come out because of quite big springs. And within the last sort of 4 or 5 years, there's been some quite significant cave systems been discovered, including the one on the right there, Excalibur Pot by the York Caving Club. And they've discovered quite an extensive cave system. But there are actually some quite major stream sinks all the way along where these rivers cross. So zooming in a bit, so I'm going to talk about two key sites here. This one and then the site over near Scarborough. So here you've got the geological map, and you can see that you've got some rivers coming down from the north, draining down through across the Corallian outcrop, which is most of this pink and yellow unit here. So the multi-oolite and for example, and as it does, the rivers sink, particularly in dry weather, and then come out at a big spring here at Bog Hall Rising. So both the River Dove dries up in summer, and also the Hutton Beck, and both these streams have been resurged at bog hole risings, which is quite a big karstic spring. And when people have used trace tests using putting dye into stream sinks or boreholes, they've discovered it taking about 3 hours for the water to go from Hutton Beck here to the springs at Bog Hall, so quite fast. And as I say, the York Haven Company have been doing some work here, digging, open some cave systems in this area here, and they've discovered quite a big cave system called Excalibur Pot, which is also linked to Jenga Pot. So this is what they discovered. So this is the Hutton Beck. It's normally in normal weather sinks in this at the top end here, but in flood it carries on further down and sinks at various points further downstream and on down further down the valley. But they discovered a cave system here, broke through into about 4 or 5 kilometers of cave passage, and discovered the underground stream which flows down through here down to the main streamway. And then in more recent years, they've also pushed further south and then coming down all the way down towards series of passages further south again, where they've intersected the main streamway here. So they basically identified much of the underground conduit system between the stream sinks and the springs. So that's so the total length of the cave system is now about 3.8 kilometers long. So it's probably about one of the longest cave system in Jurassic limestones in the UK. You get other cave systems in the North York Moors in the Jurassic limestones. Many of those are actually what they call windy pits, which are formed by mass movement, where you're getting cambering and gutting formed by movement of the limestones above clay mudstone-rich rocks to create these mass movement caves. And there are many of those in the Jurassic rocks too, but they're not karstic per se. So this is kind of what the cave looks like. You can see it's some quite big, relatively big pastures, nice big streamway, and yeah, you can have and so I say quite extensive. So very akin to a typical cave system you see, for example, in Derbyshire or the Mendips. When you come further east towards Scarborough, further along the outcrop, some of the other rivers crossing the Corallian outcrop also sink underground. This is the River Derwent, sinks in a whole series of swallow holes in the Forge Valley, and trace testing work has proved that you can trace some of the water sinking in these stream sinks to boreholes in the area, including public water supply obstructions. And they've been picked up in quite a few boreholes, with very, very rapid groundwater flow velocities of up to 13 kilometers per day, up to distances of over 7 kilometers. So clearly a very, very rapid, well-developed conduit network within the Corallian limestones here. Of course, it has implications for groundwater flow and contaminant transport as well. So so if you're looking to kind of protect your groundwater sources, for example, for water supply, then it helps to know where your water's coming from. So that's so that's a brief introduction to the North York Moors. Coming to the other end of the country now, down in Portland. Again, it's another area where you've got some interesting karst features. So the Portland, Isle of Portland is well known for the Portland stone, which is used as a building stone, and also contains some quite big ammonites as well. But it also contains cave systems too, and some of the quarries and the cliff sections around the coast have exposed some cave entrances. And these are quite interesting because there's quite an extensive a series of relict phreatic cave passages. These are the ones that form below the water table, but are now been abandoned and drained and now relict. But some of these are quite extensive. Sandy holes up to about 1.6 kilometers long. These caves aren't particularly big. A lot of them involve crawling. But what's also interesting about them is that they've intersected a series of, again, these mass movement caves where the cliff is beginning to kind of extend into, you get these cambering and gulling features, and these form vertical open rifts. So you often find that you'll be crawling along a phreatic tube formed by dissolution, and you suddenly intersect one of these vertical open rifts where there's been mass movement and extension along a fracture, and you get a quite complex network of passages combined with the two. And so here's an example of the West Cliff Caves, the west side of the Portland, where you've got a phreatic conduit aerial tunnel here coming down Sandy Hole, but particularly in the north you've got a number of these vertical fractures formed by mass movement, like this one here, Steve's Endeavour, for example. Likewise here you can see that over on the right, the Grove, a very rectilinear network of fractures that have been opened by mass movement, connected by dissolutional conduits. So it's quite interesting from a geomorphological perspective, the interplay between dissolution and mass movement. So moving back up to Lincolnshire now, the East Midlands, quite an extensive area of karst associated with the Lincolnshire limestone. Again, lots of stream sinks, some big springs, many dolines, not many caves. In fact, I don't think any caves are known in this area here, but that's probably because no one's dug them open. And in this area here, most of the stream sinks are associated with water flowing off the overlying Lowestoft till. So you've got glacial till covering the area, and where the edge of the till, water comes off and sinks into the limestone, creating a series of stream sinks and blind valleys. And then this water then flows to springs to the border at the east. So there's a particularly good stream sink here at Burton the Coggles, which is next to the East Coast main line. You can just about see it if you're going on the train, if you look quick enough. And this is an old BGS field strip from the 1940s. And you can see the stream coming in, and it sinks into a base of a depression. And the note there on the field strip says that after very heavy rain during the night of 22nd of November 1940, a lake was formed, and the field geologist was told that this would soon drain away via the swallow hole, and that actually clearly does, because this has been traced to the springs over at Bourne. And it's quite an impressive feature. So some work here was done by Tim Atkinson, who used to be at UCL, doing some tracer testing with some of his PhD students, and they did quite a bit of tracer testing work, putting in various dyes into some of the stream sinks in the east, and then seeing where they came out. And I say most of the water comes out at the springs along that eastern side, particularly at Bourne. Again, with quite rapid flow paths of, with transmissivities of over 5,000. So pretty rapid flow through times. So clearly quite well developed, probably fracture guided karst system. And when you look at the LiDAR data, you can clearly see the influence of the glacial till on the geomorphology, because you can see that at the edge of the till is often marked by a whole series of dissolution dolines, where you get water coming off the till and then sinking into the limestone. So that's the A1 there. So you can see that you can pretty much mark out the edge of the till by the line of dolines, and some of them clearly got take water, because you see little stream channels going into them. So it's really quite well defined. So the beauty of LiDAR. So moving back further south again to the Cotswolds. So this is in the Uditic limestone. There's a great light in the inferior light. Again, you've got a series of Uditic limestones interbedded with mudstones, and some bioclassic limestones within, for example, the Forest Marble Formation. And you do get, again, quite common small stream sinks, mostly quite small and ephemeral, but stream sinks nonetheless. You get areas with quite extensive dolines. There are a few small caves known, but not particularly many. And you get some quite big springs. And the other thing you see in the Cotswolds quite widely is you get these areas where you're getting water. Some of the larger rivers will often lose water into the aquifer in some areas, and then gain in other areas. So you get these areas of losing streams, gaining streams. And that's linked to the development of karst within some of these limestones. Again, like in Portland and up in the North York Moors, you do get these mass movement caves as well along the escarpment. These skull caves. This is one here, Sally's Rift near Bath, which is about 350 meters long. Some really quite big rifts. Yeah. So yeah, plenty of dolines in places. So this is the pink dots here are all mapped dolines, and this is Western Bur Arboretum for those of you who know it. So just goes to show there is quite some significant karst features in the area. Moving back down south again. So the Vale of Wardour. So this is just west of Salisbury. So Salisbury's just off to the right there on this map. You've got basically a valley cut down by the River Nadder, cutting through the chalk into the Upper Jurassic limestones. And again, you've got a whole series of stream sinks developed, where you've got the upper green sand and the gold clay and the lower green sand, water coming off those and then sinking where it meets the underlying land and also in some cases the Purbeck limestones underneath. So some quite significant stream sinks, particularly in the area around Chicks Grove. There have been a few small caves found, but nothing particularly big. But there is, like to be, I think there probably will be more to be found. But yeah, and there's been very little work done in this area in terms of trace testing. Well, no trace testing work has been done. So, but I suspect some of these stream sinks flow to springs in the Nadder Valley here. So that's the Jurassic karst. We also got some Jurassic karst up in Skye. There's some associated with the Breakish Formation limestones around Broadford. Some small caves known up there, although not particularly extensive. They've got very, very limited outcrop. And there are other stream sinks and dolines, for example, in the Blue Lias limestones between Mendips and Bath in particular, and elsewhere. So there are karstic features pretty much anywhere along that Cotswold escarpment, really. But yeah, moving on to the chalk now. Yeah, the chalk is probably Britain's most important karst aquifer in many ways. It's got a huge outcrop from all the way from the Yorkshire Wolds all the way down to Dorset, Isle of Wight, and Dover. And in quite a few areas, it's got some quite significant karst features. So it's got some of Britain's largest springs. It's got many stream sinks, probably more stream sinks on the chalk than the Mendips and Derbyshire combined. It's got well-developed dry valleys, many dolines and dissolution pipes, some caves, and plenty of evidence of rapid groundwater flow. And the interesting thing about the chalk is that a lot of the karst conduit networks, for example, have quite a strong stratigraphical, are influenced strongly by the stratigraphy and stratigraphical discontinuities. And of course, that has a big impact on engineering and groundwater properties. So why is it important? So, well, clearly the chalk is the UK's most important aquifer, supplies groundwater to millions of people in southeast England. And there are two key issues with groundwater in the chalk. One is that there's an issue with the resource in terms of quantity. We've got growing demand for water in the southeast, but also issues with low flow streams, climate change and drought. So there's a big, there's quite a lot of concern about streams drying up and damaging some of the ecological habitats. We've also got a water quality issue with issues to do with rising levels of nitrate, pesticides, and other contaminants within the groundwater system. So that's the other one of the other key drivers for needing to understand the chalk and the chalk karst aquifer. As you know, the chalk's got many, it's quite famous for its chalk streams. We've got most of the world's chalk streams in this country, and of course they're quite precious and valuable freshwater ecosystems. So so if we're going to use the chalk aquifer for groundwater, then clearly we've got to understand from how it's getting to your source and how to protect these chalk streams and habitats but also how to mitigate against contamination. So we work quite extensively with the water companies, but also the EA to try and improve our understanding of the chalk aquifer. You can't just pump water out of the ground without really understanding where it's coming from and how it got there. Chalk karst is obviously also very important for engineering projects because if you're going to, because you have issues with dolines and sinkholes in the wider sense of the word, very irregular rock head, issues with reduced rock mass strength and integrity if you've got a lot of dissolution within the rock. And understanding the karst has had, is quite important for things like, some of the big projects like HS2 and the Lower Thames Crossing, for example. So what evidence is there for karst in the chalk? Well, we've certainly got plenty of dolines. Although that said, when you look at sort of LiDAR imagery of the chalk outcrop, there are many, many thousands of closed depressions, but the vast majority of these are actually old chalk pits. Chalk was dug for and then used for marling the soils, acidic soils back in medieval times, all the way through to Victorian times. So most of the depressions that you see, perhaps in air photographs and LiDAR, are actually old pits rather than natural dolines, but you do get plenty of natural dolines too. You'll often hear about sinkholes in the media on the chalk too. Again, the vast majority of those are not natural dissolutional sinkholes, collapses. Most of them are due to actually collapsing old chalk mines and dean holes, particularly in Kent and in the home counties, because the chalk used to be mined in many places, particularly in Kent, for digging out the chalk to spread it onto the fields back in the medieval times. So most of the sinkholes you hear about in the media are the collapses of old mines rather than natural ones. But you do get natural ones, and you can see here there's a picture of one formed after a burst water main. And what happens is that you get as many what we call dissolution pipes, where you got a very irregular rock head and essentially buried dolines infilled with sediment. And what happens is if you add water to that, you can compact sediment and cause a collapse of any metastable cavities within that sediment and cause subsidence at the surface. There's one case where somebody emptied their swimming pool onto their lawn and caused some dissolution pipes to compact and subside. But you do get plenty of natural dolines around, particularly around the Paleogene outliers, where you're getting mudstone-rich rocks overlying the chalk, and you're getting water draining off those and sinking into the chalk around the margins. And I say, there are many of these buried dolines, particularly beneath the clay flint and river terrace deposits. And some of these can be, often 10, 15 meters deep, and sometimes exceptionally up to 40 meters deep. So here's an example from Dorset, where you're getting sort of sandy Paleogene deposits overlying the chalk. And because it's sandy, water can go through the sand and dissolve out underlying chalk, and then the sand basically falls down into any cavities produced. So you're getting a very irregular rock head, but then you get these substances like Sophosion dolines at the surface. And some of these can be pretty big. So the largest is the Culpeper's dish, which is up to about 40 meters deep. But you can see here where you can basically see the outcrop of the Paleogene here, where you're getting all these dolines. So they can be quite extensive with large numbers of dolines. So they're particularly common where you're getting sandy Paleogene deposits overlying the chalk. Where the Paleogene is more clay-rich, for example, in the Reading Formation west of London, then you tend to get streams flowing off and then sinking at the edges rather than flowing through the sand into the underlying chalk. Here's another example from the area just west of London around Beaconsfield. So the M25 here is off to the right, the red line, and the line of HS2 is here, the purple. This is the Misbourne Valley. The red dots are stream sinks. We have a borehole record from here that was done in 1911, and you can read the borehole record. And basically, they drilled a borehole, and they hit a large cavity at 54 meters depth, and then lost the drill bit. And then, basically, so to create another borehole next to it, and then that one also hit a large cavity at depth and went through 16 meters of sand and clay infill within the chalk before hitting back into the chalk at depth. So clearly some big dissolutional cavities within that borehole. Likewise, when they were building the M25, they did the site investigation boreholes, and at Slade Oak Lane, there's a bridge, and one of the boreholes there proved dissolution pipe 37 meters deep. So again, quite significant. So, and also in this area here, the Misbourne comes down here, and it basically usually sinks in its bed in Mount Amersham, and then it's dry usually most of the year before they're coming this big springs back over here. So I suspect the water probably flows through to the River Colne over here, coming out of the springs in the Colne Valley. So again, yeah, so quite significant karst in the chalk west of London. I mentioned sinking streams, lots of them. Again, usually associated with the Paleogene strata, sometimes with nice developed blind valleys. Most are pretty small and ephemeral, but some are actually can be quite significant. The biggest is at Water End, which is near Potter's Bar in Hertfordshire. This has actually got the biggest catchment area of any sinking stream in England, so bigger than anything up in the Pennines or in the Mendips, for example. Although it's not the actual volume of water is probably less than some of the stream sinks up in Yorkshire. And like as I mentioned with the streams flowing across the Corellian outcrop in Yorkshire, up in the North York Moors, you often find that many of the chalk rivers actually do lose water across parts of their reaches in some periods of the year, so often drying up in the summer, and then flowing again in the winter, and under periods of high groundwater levels, particularly like, for example, this winter, you often find ephemeral springs will start occurring much higher up in the catchment. So yeah, lots of stream sinks. You can see some examples here. That's one in Essendon and Hertfordshire. This is one down near Hungerford. But the largest ones are the Water End swallow holes. So this is so to just tell you when this is the M25 here at the south. This is the A1M going north, and the Mimshaw Brook flows north here, and then sinks at a place called the aptly named Water End. Some of the tributary streams also sink at various places, and the red dots are all observed stream sinks where water has been seen to sink. This one over here is St Catherine's Bourne, which again sinks here. Under high water levels, and the water actually then flows across and to an overflow channel through here. So mean flow is about 80 litres per second, but in very wet weather it can be much greater than that. Under normal conditions, the water sinks here and then flows off to springs to the northeast and coming out the River Lee Valley about 10 kilometres away. But in flood, it overflows and then actually flows into the River Colne Valley, which is off to the west. So you getting a catchment divide, if you like. As with any surface stream, you get all sorts of rubbish coming down in the stream and disappearing underground. So you can see one of the stream sinks here. But the Mimshaw Brook is got a number of old fridges and freezers and things in it too. And of course, that water's got to come out somewhere, so we often have big springs. So many of the chalk springs are large. We've got at least 25 springs where you've got discharges over 100 litres per second. Some of these run turbid after heavy rain. So this is a nice example on the right here from a spring near Hungerford. Nice blue water coming, clear water coming out under normal conditions, but after heavy rain it runs turbid. And that's fed by some stream sinks on the Paleogene about 2 or 3 kilometres to the south. The biggest spring is actually the Bedhampton Springs near Portsmouth, with a combined flow of about 104,000 metres cubed per day. So it's pretty big. And it's the main supply of drinking water for Portsmouth. Tim Atkins and others did some trace testing here in the 1970s and just proved that water comes from stream sinks up to about 5-6 kilometres away to the north. And when you look at the kind of the geology in the area, what you see is that this is kind of the cross sections through the South Downs. You're getting recharge in the South Downs, autogenic recharge, some allogenic recharge off the Paleogene into stream sinks around Horndean, which is these are the ones where trace testing was done, and then water flows beneath the Paleogene, underneath the Chichester syncline, and comes back up again to the springs at Bedhampton, or flowing into the sea. So there's clear, quite extensive integrated conduit network, going right beneath the Chichester syncline. And what various people have done over the years, particularly Tim Atkinson and others, have done is do some trace testing in some of these areas, either from stream sinks to springs or from borehole to borehole, using either fluorescent dyes such as fluorescein or rhodamine, optical brightener, or in some cases bacteriophage, because the last thing you want to do is turn a water supply bright green with fluorescein dye. So you have to be quite careful about how you undertake trace testing in chalk catchments. And so you've got a whole series of traces that have been done, and what's quite clear is that some of these trace tests have been proved over, it's quite significant distances, often several kilometres. So the one in Hertfordshire, that's the water and the swallow holes, potentially up to 8 to 20 kilometres. And the velocity of these trace tests are actually pretty fast. So you're getting groundwater flow of several kilometres per day in many cases, where you're getting a good conduit network present. So clearly karstic conduits present, linking the stream sinks to the springs. You can also have unintended traces tests. This is an example from Hertfordshire where we had a bromate spillage at a place called Sandridge, where basically a factory was disposing of bromate down a borehole in the factory floor, straight into the chalk aquifer, and it basically was detected it in various boreholes down dip. And what happened was that this is actually the water and the swallow holes here, and again in here, and these have been traced to the springs over towards Hertford and Ware, 10 kilometres away. And this bromate spleen basically intersected that karstic conduit network and then was detected at the springs in the River Lee, over 20 kilometres away. And this right-hand diagram here indicates how the complexity of the trace of the conduit network. So you get multiple input points, and if you put in dye in some of these stream sinks, it will come out at more than one spring. So clearly quite a very complex and probably a anastomotic conduit network within the chalk, feeding water very, very rapidly to these springs over long distances. And of course, not just water, but also potentially contaminants. And yes, we do occasionally see caves and conduits within the chalk, or pits and coastal sections. And as I mentioned before, they're guided by stratigraphical features, usually marl seams, thin clay bands within the chalk, sheet flints or hard grounds, but also in some cases changes in lithology. So the one on the left here is a pit near Marlow, where you're getting with conduits developed on top of it. The one in the middle is actually Dieppe, actually in northern France, but you've got the Seven Sisters Flint within the Seaford Chalk Formation here with the conduits above. And this is on the coast at Thanet, where you've got a fault plane here and a sheet flint, and you've got the conduit developed at the fault plane sheet flint intersection. So just like in a normal cave system within the Carboniferous limestone. Longest cave we've got in the UK chalk cave is Beachy Head. It's 350 meters long, again developed on a sheet flint. It's not particularly spacious, it's mostly crawling, but there are bigger cave systems in northern France, particularly around Rouen. Of course, this has a big impact for groundwater. So groundwater sources are often defined by source protection zones. We have a source protection zone 1, which is the area around the obstruction, and that's defined as a 50-day travel time from any point below the water table to the source. And this is based on groundwater models. So this assumes that chalk is a single porous medium. And then SPZ zone 2 is the outer source protection zone. So the green on the map there. That's defined by a 400-day travel time from the point below the water table to the source. And then source protection zone 3 is the whole catchment area that as determined by the modelling. So this is an area around Newbury. So for example, SPZ 1 around Speen and here and over in the Pang Lambourne. So the Pang Valley over here and the Lambourne Valley up over here. But these suggest that the vast majority of the catchment is going to take more than 400 days to get to the sources. Trouble is, when you do the trace testing in areas where you're getting karstic stream sinks and karstic conduits, then if you inject dye into a stream sink here at Smithfield's Copse, for example, it comes out of a spring here, the Blue Pool Spring, which has got a flow of about 200 litres per second. Travel time of, well, a distance of 5 kilometres, comes out in less than 24 hours. And in fact, you can see here, you can see the green dye coming in at the sink, and in fact, in this case here, the travel time was underestimated, and actually it turned the springs very slight shade of green. So clearly that it's getting very, very rapid flow velocities, albeit with high trace attenuation. And that contrasts strongly with what is being modelled, assuming the chalk is a single porous medium with no karst. So in the inner source protection zone 1, you might expect water to take a year to travel 6 kilometres, but we're getting that distance in 1 day, where karstic conduits are present. So the thing about the chalk is it's a very heterogeneous aquifer. In some places the matrix is, you get groundwater flow through the matrix is very, very slow. In some places you get it flow through fractures and conduits and it's very, very fast. This is a second example. You're getting monitoring borehole here with 3 obstructions, and when the tracer was injected into the monitoring borehole, it came out at some of these obstructions within pretty short order, within 14 hours. So much faster than the modelled 50-day travel time. So the green circles is basically the modelled SPZ zone 1. So clearly, very rapid flow times with potential for rapid transmission of pollutants. So there are alternative ways of defining source protection zones rather than using groundwater modelling. So you can various different ways of doing it, but you can come up with different source protection zones. So just to wrap up now, then. So there's evidence for karst across the UK. So these stars here just show that some extreme examples where you got cave systems and Durness limestone up in the north coast of Scotland at Smoot Cave. You get caves and karst features down in Devon and Pembrokeshire, Isle of Wight, Holyhead, Anglesey, Flamborough Head, the Antrim coast in Northern Ireland, down in Dover. So there's a wide spectrum of karst features across the UK. Yeah, we get them in neopressuric metacarbonates. We get them in the Cambrian Durness limestones of Scotland, Devonian limestones, carbonate limestones across, particularly in Peak District, Yorkshire Dales, around Cumbria, North Wales, South Wales, Mendips, Forest of Dean. In fact, Forest of Dean, they just discovered a 15-kilometre long cave system. We get it in the Permian breccias and gypsum deposits and Triassic salt. We get them in the, as I mentioned, we get them in the Jurassic limestones, and also in the chalk. So it's an understanding that the extent and the style of karst is important in terms of groundwater management, identifying karst hazards, sinkhole development, that kind of stuff, and drilling development, but also for infrastructure development. So I shall leave it there. So any questions?
Thank you very much. So if anybody has any questions, I think you can unmute yourself or put your hand up, and I can unmute you. If that doesn't work, put your questions in the chat, and I will ask them. So while you're thinking about that, I had a few questions, Andy. So the first one is, you talked about on Portland and in Eastern England, the relationship between the Lowestoft Till and the karst, and the relationship between karst and gull caves, which obviously highlights that these features have formed relatively recently, in the last few hundreds of thousands of years in Eastern England, and I don't know what sort of age the gulls are, but are these features still forming?
Yeah, they're starting to be forming. I mean, the age of the cave systems and karst development is basically, it spans probably the last 1 to 2 million years. We've got evidence from some of the cave systems in the Carb limestone in South Wales, Ogof, for example, where we're getting uranium lead dates on speleotherms dating back to over 1.4 million years. And there's clearly some quite significant cave development going back well before the Anglian glaciation. The gull caves, again, we've got some evidence from dating speleotherms within those gull caves, and some of those are surprisingly old, actually. Some of the ones on the Cotswold Escarpment are going back, at least 300,000 years. So, which is quite surprising, but actually, they're actually quite old features. So it links back to the whole of the landscape evolution. But clearly, I mean, some of the features in Eastern England, you often get associated particularly with the Anglian tills. Yeah, they're post-Anglian in age and obviously still forming today. So,
and do we associate them formation with wet climate or cold and wet climate?
Well, most of the dissolution, most of the caves and karst systems are basically formed by groundwater circulation. So most of those occurred probably during the interglacials, but also during the glaciations when it wasn't seriously cold. But obviously, during the peak glaciations, the MAS 2, for example, 20,000 years ago, peak events, you probably wouldn't have had much groundwater circulation, so you probably wouldn't get much conduit, karstic development at depth. But yeah, so it's so most of the last 1.5 million years has been cold, isn't it? So it's
and thinking about climate change with projected rainfall patterns changing to being much more focused and intense, do you think that could lead to more doline formation? I mean, I'm wondering whether it's analogous to these water main bursts causing dissolution hollows.
It's interesting that most of the spikes in sinkhole events in the media are usually just formed due to very wet winter weather. So for example, 2014 we had a whole spate of sinkholes across the UK, of which the vast majority were due to collapsed old chalk mines and things like that. Including one that closed the M2 in Kent. But there was almost certainly an increase in natural daily formation, but because they tend to be smaller and often in more rural areas, it just didn't get the press attention. So, I mean, you often see active sinkholes in some of the up in the Yorkshire Dales and the Mendips and elsewhere, but unless the impact infrastructure or somebody's house falls into them, that you don't really hear about them in the media.
Interesting. Okay, I'll open it up to the floor. Does anybody have any other questions they want to pose? There's nothing in the chat and no hands up, so maybe people are keen to dash off and get some food. Okay, well, thanks again, Andy. That was a really interesting talk. Much appreciated to take us through the story of karst around the UK and the implications to engineering, contamination, hydrogeology, etc. For everybody else, thanks for contributing. We will have ongoing talks in future months, so keep an eye on the BSG mailing list and also our LinkedIn page. So I'll close there. Thank you very much, Andy. Thanks all.
Okay, take care. No worries.